Let me see. And so you're seeing full screen now?
Yeah.
Okay, perfect. So this project right in the middle, the short name of it is Follow Me Into Math. And you'll see why the logo has that shape where these two gears are here moving together, and they're kind of like heads together. So we thank also the organizers of this conference for accepting the paper, and we're excited to spend our 15 minutes to present to you a little bit about this talk. So this is we're calling this an intervention study, where we're going to schools and we're doing math shows. I'm going to tell you a little bit of the background of this, and then my colleague John Knight will present some of the preliminary quantitative data. My colleague Eli Patiño will present some of the qualitative data. So it's a mixed method study, and we're looking at the impact of this intervention. So here we are going to high schools, and we're doing shows. We're showing them some floppy geometry, that's hyperbolic geometry there on the right with crochet. They're doing a number line dance at the bottom where they're discovering the complex plane. Here we see there's no sound to the video, but you'll see it's this large groups of high schoolers that we present to, and they're rolling these big, huge dice, trying to land on prime numbers for a certain kind of game that we call prime climb. And so we have a lot of fun with the students. And the idea behind this, we draw from engineering, where Lichtenstein said that one positive exposure to engineering has the potential to impact high school students' academic decisions to pursue engineering in higher education. Substitute mathematics, that's what we're doing. We're trying to have this little interruption to their Algebra 2 life. That's the level we're working at right now, is Algebra 2 students. The ones you saw earlier were geometry students. Now we're working with Algebra 2 students. And so this is, so I'm going to draw a little bit on the literature. We do experiential learning, like Kolb said. There we are discovering the birthday paradox, that a large number of people in the room will have the same birthdays. But we made an observation along the way. First, us professors were doing this talk. Here I have just asked for volunteers, and you'll see the face right here. He's saying, no thanks, please don't call on me. Well, when our students began to do the shows, the green-haired guy up on the left was an undergraduate student, and look what happens when he asks for volunteers. Okay, so it seems like we saw a difference. The peers matter. When the undergraduate students were the ones doing the presentations, the high school students were more ready to volunteer, to participate. And so we started looking at this through the lens of identity. Anderson gave us the 4 phases of identity, where engagement, imagination, alignment, and nature combine to help people to align with or against mathematics. Martin also gives us some of the foundational ideas of identity. Grisolfi and Hand help us understand how narratives inform the identities that we shape for ourselves. So we look at our study through this model, where us college professors are mentoring college students who are mentoring high school students, and there's this kind of imagining aligning feedback that happens. Well, there's 3 things that we do. We do math shows, then we ask the students to follow us on social media until they come and visit us at the campus for a summer internships. The study has 2 components, where we're measuring attitudes towards mathematics using the mathematics, the ATMI, and we're also in a number of other identity alignment questions, and we're also doing focus groups and interviewing students. I'm going to transfer it in just a minute to my colleague to show some of the baseline quantitative measures. Look at the item at the bottom. This is one of the most interesting items to us, where we ask the students, how does your self-image overlap with your image of being a college student, mathematician, scientist, professional? It's a very easy to understand kind of item for students. We also asked them about their mother and father's background, how their jobs overlapped with STEM fields. And so I'll pass it now to my colleague, John Knight, who will present some of the initial quantitative data. This last item you're seeing here is where students have to put in order the ones who impacted them most: parents, teachers, siblings, other relatives, or friends, in terms of mathematics. And I'll pass it to John.
Thank you, Dr. Wilson. So one of our main measures from the surveys was the attitude towards math score. And this was a series of questions that were scored from 1 through 5, 5 being the highest. And given there were 19 in total, this gave a total ATM score for each student that would rank up to a maximum of 95. And you can see here that the scores were actually distributed normally. with a mean of around 60.5. So we were able to use these scores to correlate with a lot of other measures in our analysis. If we go to the next slide, please, we can see that this ATM score could actually be broken down into 4 separate constructs based on the nature of each question. And so these were the enjoyment of math for the student's motivation for math, their self-confidence in math, and their perception of the value of math. And what we found is that the value of math was comfortably the highest of these 4 scores. So students were saying, yeah, we appreciate math has value. If I study math, there's potentially a good career at the end of it. The slightly lower scores were things like, do I enjoy math? Am I motivated in math? Do I feel confident when I'm doing math? If we go to the next slide, please, we can see that this was the overlapping sort of Venn diagram things that Dr. Wilson touched on there. Do you identify as a college student, a mathematician, a scientist, or a STEM professional? And we can see when we correlate that with our ATM measures, perhaps not surprisingly, the most positive correlation seems to be with mathematician. And if we go on to the next slide, we can see that we actually ran some analysis of this with ANOVA and pairwise testing. And we found that mathematician had the strongest correlation with the ATM score. But there are also positive correlations with our ATM score and whether you identify as a college student or a STEM professional. Excuse me. And if we go to the next slide, please. So these were the questions relating to the student's parents. And if we concentrate on the column on the right-hand side, we asked them, what was the impact that your mother and father had on your interest in mathematics? And you can see that there seems to be a slight positive correlation there between the amount of impact and our ATM score. And if we go to the next slide, we've actually grouped these so you can see them a little more easily. So it's grouped 1 to 2, 3 to 5, 6 to 7. And you can see again, when we run our ANOVA tests, we can see that there were positive correlations between this with our ATM score. We'll go to the next slide, please. And so this was interesting. We asked the students to rank 5 different categories: parents, teachers, siblings, other relatives and friends, based on how much impact those people had on your interest in mathematics. And perhaps not surprisingly, the top 2 were parents and teachers, but interestingly, the students most commonly would put teachers as being the biggest impact on their interest in mathematics, with parents in second place. So they're telling us that teachers actually matter more on average than parents. We'll go to the next slide, please. So we actually had 2 separate schools that we visited in our study. So we were able to compare the scores of each of those 2 schools. And we can see here that fundamentally, the attitudes towards math were very similar in our baseline analysis between the 2 schools. But if we actually look on the next slide, here is where we were looking at the Venn diagram type identity questions. So we can see the first question was whether you can see yourself self-identifying as a college student. Kind of an even spread there, a lot of 4s and 5s, as well as 1s, 2s, and 3s. So yes, a lot of them could see themselves as a college student. In contrast, if you look below that, where we asked, can you identify yourself as a mathematician, it's very much a downward trend. Lots of 1s and 2s, not too many 4s and 5s. So also, if you look on the next slide, it's a similar story when we asked, do you self-identify as a scientist? Can you see yourself as a STEM professional? Again, very few 4s and 5s. A lot of students are saying, I just don't see myself in that identity. And if we go to the next slide, please. So this was interesting. These are the parents' education levels. And we can see that more than half of our Arm B school, which is the big blue bar at the bottom, more than half of the students had a mother who has less than a high school education. And a significant amount with our Arm A school as well. So within both schools, a large amount of mothers that didn't finish high school, but especially with our Arm B school. And if we look on the subsequent slide, which relates to the father's level of education, very similar. So this is one of the big challenges in the area that we were visiting the schools. You've got a lot of students that are growing up with parents that didn't even finish high school, let alone talking about studying math at university or anything like that. So that'll be part of our ongoing analysis, is to see how that affects students and their interest in mathematics and their grades and sorts of other things like that. And I think at this point, I'll be handing on to my colleague, Eli.
Hello, guys. Thank you all for joining us again. And so To give us a better understanding of the quantitative results regarding the alignment of the students with mathematicians and scientists, we conducted some qualitative analysis on a couple of focus group and interview transcripts. We needed to know, what do the students think mathematicians and scientists are? What is their overall perception of them? And how did they justify their level of alignment? What factors were those decisions based upon? So this is just a story of 2 independent open coding analysis. This is very preliminary qualitative data, so we can't draw too many conclusions, but there are some things that we did notice. During the focus group interviews, the students were asked to list the first 5 words that they thought of when they heard the word mathematician. Our preliminary investigation discovered that most of the students use adjectives to describe mathematicians as smart, good at calculating, insightful. Of course, this is just a summarization, but here are a few excerpts from the data. For example, the student they put equations, numbers, calculator, Harvard, and PEMDAS. So as you can see, calculator and Harvard, 2 words that they would use to kind of describe mathematicians. Human calculator, equation solver, calculates how things are going to happen, letters and numbers. And then the last person put intelligent, numbers, formulas, adding or subtracting, multiplying and dividing. So these are the words that the students just kind of, they think of whenever they hear the word mathematician. You can move on to the next. Yeah. The same question was also asked regarding scientists. The responses given for this question tended to describe scientists as people who applied their knowledge rather than just acquiring it for knowledge's sake. They were seen as people who make new discoveries by experimenting. Some students did give descriptors of scientists, which show them kind of working in labs, wearing lab coats. Most importantly, like using their knowledge of science and math when answering the question regarding mathematicians. The students didn't really give a lot of responses for how the students would use that math. Again, here are some direct quotes for some of the responses. The student put microscope, labs, DNA, lab coats, and safety glasses. As you can see, all things kind of that lean more towards applications of science. Biology, chemistry, dealing with the body, chemicals, liquids, some use of math, and good with equations. So this student is kind of saying that they use math in science. I put astronaut, NASA, physics, chemistry, and math. Another student that put that they use math as a scientist. Go ahead, Dr. Wilson. Now, how they compare. Again, these are still preliminary findings and they have to go through a little bit more of a thorough coding process, but from this data, we can start to gather some evidence that our high school students believe that mathematician is a more narrow term than scientist. Scientist was shown as a broad term for multiple career choices, such as biologists, chemists, geneticists, and physicists. It felt as though students didn't really know what mathematicians did besides being teachers or professors. Though they are seen as highly intelligent and great at performing calculations, they were kind of limited in what they thought their career options would be. Scientists were seen as experimenting in different subfields of science whilst using mathematics in those experiments as well. And so this is, the next couple of slides have to do with mathematical identity and how the students align themselves with mathematicians and scientists. This is the question we asked them in a focus group, and there's the diagram we showed them that so that they could visualize their response. The question is, how does your self-image overlap with your image of being a mathematician? And then there's a 1, 2, 3, 4, and 5 option. One thing we noticed that when it came to math was that their self-efficacy mattered quite a bit when aligning with mathematician. Most of these students interviewed justified their alignment with some connection to their self-perceived ability to do math or their grades in math. So this student put, because I'm not that good at math, but I'm pretty decent, they rated themselves as a 3. Another student said, I guess I would be a 4 because I'm pretty good at math. And these 2 students said, so you got to be pretty smart or really good at math. So that's their reason for aligning the way they did, was based off of their self-perceived competence. Go ahead. We also asked the students to align themselves with scientists, and what we found interesting was that when aligning with scientists, ability was important, but it wasn't the most important reason why the students aligned the way they did. In fact, it was interest in the topic that was found to be the most prevalent reason that the students aligned / didn't align with scientists. As you can see here, the student said, I'm a 2, I'm not really interested in science. So a lot of these, the answers to this question were a little bit more diverse than the answers given to the mathematician alignment.
Okay, our time is short, Eli, here. Can we speed up a little bit? Thank you.
So I think we can actually bring it to a close. The big finding that we'll leave you with is kind of what Eli was just saying, that when students thought about their alignment with mathematician, they really thought about how good they are at it. The skill or ability, the second pair of bars was a much greater for aligning with mathematician. But when it came for scientists, they justified themselves more in terms of their interest. So math to be a mathematician in their eyes seemed to take skill or ability, whereas scientists seem to just take interest. You could do it if you were just interested in it. And that's one of our preliminary findings. And we'll leave it right there. We thank our partners, the Donna Independent School District and the National Science Foundation, for joining us in this project.
Thank you, Jim.